Welcome to our second video on Class Notes 1-11. We did go over in our first video, we did go over some of these terms that related to the labs that we completed. And then we got into the heart of the notes, which is ways to categorize matter. And one way to categorize matter is whether it is pure. Pure means one thing there. Mixture means two or more things are there placed together. So pure means one type of thing there. In our last video, we learned that pure could be an element. An element means that you just have one type of atom there. An element means you have one type of atom there. And that type of atom is characterized by having the same number of protons. So for an atom to be the same type as another atom, they have to have the same number of protons, which is the atomic number. What are atoms? We mentioned it. Atoms are the smallest unit of the element. So if you have a pile of elements, the smallest thing in that pile of elements is an atom. The smallest thing that has the properties and characteristics of the element is an atom. The smallest particle that can engage in a chemical reaction is an atom. So there are 118 different types of elements. Therefore, there are 118 different types. If I look at a pile of atoms and find out that the atoms, every atom in that pile has 20 protons in the nucleus, what would that atom be? Those atoms would belong to what element? Well, there's the 20. They would belong to calcium. The atoms in that pile would all have 20 protons. They would belong to calcium. If the only thing in that pile were calcium atoms, then it would be pure. One type of element there, pure. An interesting question we had in the pirate alchemy, where they took a copper coin and tried to turn it into gold, and we found out you could not turn the copper atom or copper penny into gold. The only way you could do that would be to change the number of protons. They were not doing that. To change the number of protons, you would have to give it a tremendous number. It'd be like 50 protons you would have to jam into copper's nucleus in order to turn it into gold, because copper has 29 protons, gold has 79 protons. You'd have to add 50 protons to the nucleus. But when you're adding things to the nucleus or removing things from the nucleus, it's a nuclear reaction, not a chemical reaction. But in that lab, they had copper. They did a chemical reaction to get zinc to coat the surface of that copper penny. Then they heated the copper penny in the burner flame, if you remember. And what happened there is they made an alloy. An alloy is a mixture. So when they heated it, it melted the zinc atoms, it melted the copper atoms. Those two atoms mixed amongst one another, and the color turned from the silvery zinc coating color to the color that looked very much like gold, but that was actually brass. Now, when they heated it, there was no chemical reaction between the copper and zinc. Electrons were not being transferred between the copper and zinc atoms. Electrons were not involved in the melting of those atoms. So what you made was a mixture of the atoms. The copper was still there. The zinc atoms were still there. You could separate those again by other physical processes. Now in that penny, you would have the copper element or copper atoms in there. You would have the zinc atoms in there. So now we would have two different types of elements or atoms in that coin. That coin was not pure anymore. Pure means one type of element is there, made up of one type of atom. That's what they mean by pure. Pure means only one thing. So many of our coins are not pure. They are mixtures called alloys. So if we only have one element there, and the only thing there is one element, it could be considered pure. But it is something very interesting happens with some elements. The atoms of some elements want to join up with something, anything, even if it's the same atom. There are certain elements that are very commonly well known for those atoms to join together with the same exact type of atom. When two atoms of the same type join up, in other words, when two atoms that have the same number of protons join up, and it happens naturally on its own in nature or whatever, it is called a diatomic element. Di means two atomic atoms. So some elements are found with two atoms joining up. So elements that are found naturally in pairs of the same atom joined, when those two atoms join, any two atoms joined, two or more atoms joining, anytime you have two or more atoms joining together, and they're just going around together as a group, it's called a molecule. So molecule can be same atoms joining, molecules can be different atoms joining, but they join up and they just go around together. It's called a molecule. Diatomic elements are elements that have two of their atoms join up. You can never get just one of the atoms. There are 7 commonly known diatomic elements: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Many of you already knew that oxygens always came in twos. O2 means that oxygen is always found with two atoms joining up. Hydrogen is another substance where two atoms join up. So, hydrogen will always be found with one hydrogen atom sharing electron with the other hydrogen atom. They're sharing a pair of electrons there. Chlorine are two atoms that share pairs. Fluorine are two atoms that share pairs. These 7 elements are found always with two of the atoms joining. Now it spells out. You're like, a very, very important thing to know in Chem 1 are what are the 7 ones that always join up with themselves. It spells Brincklhoff. Brinkelhoff. Brincklhoff spells Brinkelhoff. Brinkelhoff. Those atoms are always found in twos. On the periodic table of elements, there are no subscripts or formulas on here because they're just telling you what one atom has. The periodic table of elements does not tell you which ones join up with themselves, but they're right here. We mentioned there's 7 of them. Brinkelhoff. There's number 7. If you just draw a little 7 right here, nitrogen, oxygen, fluorine, there's the top part of the 7. The side of the 7, fluorine, chlorine, bromine, iodine, you'll see we have 1, 2, 3, 4, 5, 6 of the 7. We're missing one. There's the one we're missing. It's hydrogen. So hydrogen is always found in twos. H2. Nitrogen, always found in twos. Oxygen, twos. Fluorine, always found in twos. Chlorine, bromine, iodine, always found in twos. Those are atoms, they're elements. The atoms of these elements will always combine. They also happen to be gases. Hydrogen's a gas. These guys are all gases. They're gases that can join up with themselves, and they do that. It's a chemical joining. It's not a nuclear joining. It's a chemical joining. And the reason they join chemically is to satisfy their need for electrons, to satisfy the octet or duet rule. Chemical reactions, chemical stability is by having certain numbers of electrons. So they join to share electrons to get their outermost level in their electron cloud filled. So that's what diatomic elements are. Two atoms, elements that have two atoms that join together so that they become chemically stable. Some elements are found in nature in numbers other than 2. Sulfur, for instance, elemental sulfur. We saw it in the physical and chemical changes lab. It was that yellow powder that they used to create a physical or a chemical change. But sulfur is found in 8s. So when you have elemental sulfur, you write an 8 after it. The S sort of looks like an 8. The S looks like an incompleted 8. So you just have to remember sulfur comes in 8s. Phosphorus. Phosphorus comes in 4s. Elemental phosphorus will always have 4s. So if you're writing a chemical equation and it says you have elemental sulfur, you have to put an 8 after it. If it says you have elemental phosphorus, you put a 4 after it. If you have any of these 7 diatomic elements and you're writing a chemical equation that involve these, you always have to put 2's after it. The 8s, 4s, and 2s are not on the periodic table because the periodic table refers to what one element has. Now, there's a name for elements that can be found joining with themselves and joining with themselves in more than one way, and those are called allotropes. Allotropes, different ways an atom of a given element can join. We know O's can always join in twos, and that's the most common way O's join. But ozone is a molecule. Again, molecule just is when more than two or more atoms of the same or different type join and go around together. O's can also join in threes. It's called ozone. You've heard about the ozone layer. The ozone layer in our atmosphere is a very important layer, but it's not a super stable molecule, and it's easily broken apart, and it's not found very common at the surface of the Earth, where there's enough molecules that it can bang into and break apart. So allotropes, different ways atoms of a given element can combine. Carbon also has allotropes. Graphite has sheets of carbon that join together. Diamonds has really three-dimensional sheets of carbon atoms joining together. Graphite's like two-dimensional sheets, but carbon can form more than one way with its atoms joining. We've already mentioned the word molecule, and a molecule is any example of something chemically joined. They can be atoms of the same element, such as the diatomic elements, or ozone, O3, or they can be atoms from different elements. So molecules can form with atoms of different elements. H2O. That's two atoms of hydrogen joining with an atom of oxygen, H2O. That would be a water molecule. Now, when we have atoms of different elements joining, it's no longer an element. It's a compound. What do we mean by the word compound? Compounds can also be pure substances if the only thing we have there is the compound. But a compound is two or more different elements chemically combined. So they're chemically joining. Molecules are the smallest unit of a chemically joined substance that has the properties and behaviors of that substance. So oxygen can be O2. O2 is a molecule made up of oxygen atoms, and the smallest grouping of those atoms that behaves like oxygen is O2. That's a molecule. Remember, atoms are the fundamental building blocks of matter, or of elements. But when those atoms engage in chemical reactions, that tells us that those atoms are the smallest particle that can engage in a chemical reaction. Molecules are essentially the fundamental block of compounds. But the key feature of a molecule is that they're able to join and move around together. So to understand molecules, here I have a container, and let's say this is a bromine atom, a bromine atom, a bromine atom, and a bromine atom. These are 4 bromine atoms. Inside this container, I have the element bromine. Element just means you have all atoms of the same type hanging out together. If this bromine atom, though, this bromine atom is looking to find another bromine atom because bromine's diatomic. Those two could join up. This one's looking for an atom. It could go find another bromine and join up, and now we have Br2, bromine. This is a bromine molecule. This is a bromine molecule, because wherever this atom right here goes, this one's going to follow. Wherever this atom goes, this one's going to follow. Here I've got another container. In this container right here, I have 2 hydrogens joined up. And this would be a hydrogen molecule. I have 2 hydrogens joined up right here. This would be a hydrogen molecule. They're going around together. Here I have 2 oxygens joined up. They're hanging around together. Inside this container, it's not pure because I have hydrogen element or hydrogen atoms joined up. Hydrogen atoms joined up. So I have the hydrogen element in here. I have oxygens joined up. I have the oxygen element in there. I have 2 different elements in there. That's not pure. In chemical reactions, things break up with who they're with. So if I have a chemical reaction, these oxygens could break up. In chemical reaction, these oxygens could break up and join up with these hydrogens. Now I have water molecules, H2O. These water molecules will go around together. And we only have one thing inside here,